Hello makers, welcome to 3D Maker Noob. I'm Joe and today we're going to talk about the Creality CR-10 Mini. Stick around. Welcome back makers. So today I'm going to talk to you about the Creality CR-10 Mini. Yes, this is the little brother of the Creality CR-10 which I've reviewed a couple of months back. Now Creality have been extremely busy recently because their CR-10 lineup was extremely successful. There was a very specific reason for that. One, it was very affordable. Two, it had an amazing build quality. The printed parts were actually quite beautiful that came out of it. So obviously after that happened, a lot of other companies tried to jump on that bandwagon. There was the Tronxy X3S, which was a kit which I have here, which I will talk about in another video. There was the Attn E10, which was touted as the CR-10 killer, which it truly was not because it was a smaller form factor. So what happened was Creality said, okay, you want to do a smaller version that's a CR-10 killer? Let us do that. And this is the result. The CR-10 Mini boasts a print volume of 330 millimeters on the x-axis, 220 millimeters on the y-axis, and 300 millimeters on the z-axis. As the CR-10, it comes almost fully assembled. You only need to put together a few screws. The frame is made out of V-slot extruded aluminum and rollers. It also comes with a bow down setup, a standard brass 0.4 millimeter nozzle, removable glass build plate. It has a 12 volt 30 amp power supply which helps it quite a lot. The wiring in true Creality form is absolutely spot on. Everything has the proper connectors and it's done in the right order. It still comes with the external MOSFET which was so popular on the Creality and runs on an SMLZ board. However, there are a couple minor differences than the original CR-10 which you can see as an upgrade, and that is there are no more 3D printed parts. Starting from the y-axis belt tensional, which is now made out of a steel frame. You no longer have the 3D printed fan shroud for the part cooling fan. Instead, you have injection molded plastic, and they have also put a bracket to hold the Z-axis lead screw in place, and I'm not entirely sure that was a very good idea. And all that will cost you $369. Yes, that's $30 less than the Creality CR-10. So what about the prints? Now, this is going to be a bit of a different review than I usually do because usually I just print quite a few things which I really enjoy or which I like online, but it's not that consistent when it comes to many 3D printers and doing reviews and try to do a comparison. So the reviews will now be based on some consistent factors, and that is always printing the same exact things on all printers in order to get a benchmark for each printer. These will range from a lot of 3D benchies at different speeds and different layer heights. It will be done with different materials. There will be test prints done from the SD card that comes with the printer, and every single printer will get the same exact treatment in order to get a good benchmark. As you can see, I will also print a few trinkets here and there, which mainly we'll look at reliability because every printer from now on, before it goes to review, has to do a minimum of 100 hours of printing. And for example, this color right here, that took 62 hours to print. So on to the prints. And the first print I did was this cat right here, which came off the SD card that was supplied with the printer. It was printed with the white PLA, the generic PLA that came with the package. And I have to say that it turned out exceptionally well. It's not that I was impressed because I know that the CR-10 produces really good quality prints, but this came really, really nice. So I was very happy with that. Next up, I decided what else can it print with cheap PLA, because I get a lot of people asking me, can it print with cheap PLA? So I decided to print a benchy. And this benchy was printed at 200 microns and 50 millimeters a second. And I have to say that it printed extremely well. So yeah, it can definitely print with cheap PLA. Next, we'll start with the generic prints. And I know that a lot of you don't like benchies. I personally love benchies, but the reason why I'm using benchies for this particular test is because first, it's recognizable. Two, at some point, everyone will print a benchy. And three, you can actually compare the quality of a benchy that you see with one that you print. so you can tell whether it's better or not. So first up is the 100 micron Banshee. This was printed in ColorFab PLA. The print speed was 50 millimeters a second, and I have to say, for 100 microns at that speed, this came out quite good. So I was actually quite impressed with this. Next up are the 4 Banshees right here, and these are all printed in 200 microns. However, the difference is we have one at 30 millimeters a second, there's one at 50 millimeters a second, one at 70 millimeters a second, and one at 90 millimeters a second. And the reason I did those speeds is because a lot of people ask me, how fast can you print with the printer itself? Now, I want to point out that I actually didn't change much out of all of these. The only things I changed were for the 70 and 90 millimeters a second, I increased the extrusion temperature by about 5 degrees just in order to keep up with the additional flow of filament that will come out. However, other than that, all I changed was the speed. And I have to say that while it's 70 and 90, it's not a flawless print. It actually printed quite well. So yeah, it can definitely print at faster speeds. However, from what you can see, obviously the 50 millimeters a second printed very well, and the 30 millimeters a second printed almost flawlessly. Next up, I wanted to print something in PETG, so I printed this spool holder right here. This was printed in a Printer Pro PETG. Now this prints in 4 parts. You have the spool holder itself, you have the stand, and you have the 2 clips to put it in place. And the reason why I printed this is because if I'm going to be printing so many test pieces, I want to at least try and make good use out of the plastics that I use. Now, PETG printed absolutely fine. There was a bit of retraction issues and there wasn't any stringing actually. The only problem was that by the time that the nozzle moved from one place to the next, it started oozing out a bit, so adjusting the travel speed of the nozzle would definitely fix that. However, in terms of temperatures, it has no problem reaching bed temperatures of 70-90 degrees in about 5-6 minutes, so it is excellent for stuff like that. And the nozzle had no problem reaching the temperatures as well, and as you can see, at 200 microns, this actually printed quite well. Next up, I decided I want to see how it handles flexible filament, because it's also a question I get asked a lot. So I tried 2 test pieces, which are these octopus right here, or octopi. The blue one is printed in TPU, and it's rigiding TPU, and it was printed at 30 millimeters a second. Seeing as this is a Bowden setup, it's very important to print very slow. Now the purple one is a bit of a softer type of flexible filament. It comes from Poland. It's a company called Fiberlogy, and this is the FiberFlex 40D. It actually prints gorgeously. I printed this at about 15 millimeters a second just to make sure, because it's much more flexible, as you can see, than the TPU. However, it handles stresses quite well. It seems quite rigid, so I'm trying to find more applications where I can use this. However, even though it's a Bowden setup and no fancy extruders, printing at the right speeds with the right settings, you can definitely print it flexible. Next, I tried to print in ABS, but that was an absolute failure. These are some parts I tried to print in Azure Film ABS. Unfortunately, just the layers didn't want to bond at all. The fact that it's completely open and it's getting a bit cold, yeah, trying to print in ABS is pretty much redundant. However, from perspective of it being able to reach the temperatures of 100 degrees on the build plate and 250 degrees on the nozzle, yeah, it definitely reached those quite easily. Next up was to test the claimed speed of the CR-10 Mini. Now, Creality state that it can print up to 200 millimeters a second, and I decided to put it into practice. Now, this is the Pegasus model by 3D Printed Aspie, and it's printed at 200 millimeters a second. Now, I want you to keep in mind that this is sort of like an overall speed for simplified 3D. You put it at 200 millimeters a second. Now, seeing as it kind of slows down for the border and possibly reaches 200 or 150 or 60 millimeters in the infill because it has to accelerate and doesn't have enough time to accelerate, The average is about 80 millimeters a second when you take it as a whole, but the top speeds did reach about 141 millimeters a second because you can check all of this online. As for the print quality, I definitely wouldn't recommend printing at that speed because, as you can see, you will definitely not be happy with the result. However, having said that, the fact that it actually printed and it printed the whole thing, it was quite impressive. Can it print at 200 millimeters a second? Yes. Can it print well at 200 millimeters a second? No. So then it was time for some reliability test, and the first thing I did was throw in some Filamentive RPLA white and put in this Death Trooper skull, which was on my mini factory. This prints in the upper orientation, so it prints facing upwards. It had a lot of supports. It took about 63 hours to print this, which was a very long time. Wife wasn't very happy, but it came out incredibly beautiful. I was very happy with the result. Granted that the back where the supports were is not perfect. I wasn't expecting it to be. However, with some tender loving care, some sanding down, some fine tuning, some painting, this will look absolutely amazing. Next up was this yellow tower here. I received some more Filamentive RPLA. They have some new colors out, and this is their yellow, which looks absolutely incredible. And I decided to print this lantern. Now, this is the whole model. There is another model where you can take the top off and put a light inside, so you kind of have like a night light. It looks absolutely amazing. This took about 35 hours of printing, and I have to say that once again, it turned out absolutely gorgeous. There are a few things which I'm not convinced about, and it's possibly due to my retraction settings, but there are some layers which seem to be slightly under extruded, or the extruder couldn't keep up with the retraction part of it. However, everything else printed beautifully. And finally is this make test right here. Now, I didn't do the whole make test, but I did enough that I can test out multiple printers and get a benchmark. I enlarged. This is supposed to be about 10 centimeters high, but instead it's about 30 centimeters high. And I wanted to see how the printer performs once it starts going higher and higher. This has a single lead screw, so I wanted to see exactly how it performs. Now, while it printed well, going slightly to the top, you can see that there was some kind of it wasn't a layer shift, it was more like a section shift where it kind of moved outwards and then back inwards. And it did it both in the X and the Y orientation. Now, as I said, just to make sure before you guys tell me it was my settings and all that, the same SD card is being used on several different printers to print the exact same thing. So currently, I'm also testing the CR-10S, which is the upgraded version of the CR-10, and the TiVo Tornado. And as you can see, I printed the same exact thing on all three printers, and it's the same SD card, same settings, same filament, same day, just to rule out any variables. And funny thing is that the CR-10 Mini had this section shift, which was quite big actually. The CR-10S also had the same thing, but on a very smaller scale. The TiVo Tornado, on the other hand, is almost flawless. So I don't know exactly why. It could be the concentric nuts need to be adjusted, or it could be the fact that now the Z-axis lead screw is kind of held in place, so it might have a role in that. But the Tornado is also the same way. It's still eccentric nuts, it's still a single lead screw, and it is 40 millimeters high, 400 millimeters high. But it printed quite well, so this is something I still need to investigate. Next up was bridging, and in terms of bridging, it's not the best. Even when it comes to the smaller bridges, it still didn't perform as well as I would have liked it to, but at least it held its bridges, so I can't fault it for that. Next is the tolerance test, and the way this works is that if the pins in the center of the block just come out, then that tolerance is spot on. As you can see, up to 0.3 millimeter tolerances or space between the pin and the hole, they come out perfectly. However, 0.2 is completely welded in place. Next is the detail, and this came out okay. I've had pretty much the same exact result on all the printers. The only thing I can say is probably my retraction settings needed a bit of dialing in. However, in terms of fine detail, it can definitely print those. Finally is this little tower right here, and this tower helps you understand the calibration of the printer in terms of the X and the Y to see exactly how they are compared to each other in terms of calibration size. Now I have my trusty calipers here, and once I set them to 0, it's not perfectly calibrated in terms of X and Y. So while one of the lower circles should have a diameter of 20 millimeters, it starts off between 19.92 millimeters and goes all the way up to 20.04. Squeeze it a bit more, 20.03. And that's almost 0.1 of a millimeter. So that's 100 microns. That's quite a lot. And the more you turn around and the more you test, you can definitely tell that there's some discrepancy. So for example, the upper one should be about 10 millimeters. Instead, it's 9.89, 9.95, 9.94. So it plays around quite a bit, so it definitely needs calibration on both axes. And that is it. That is what I've been doing with the CR-10. It's very important for me to ask you guys, what do you think about this style of review? Do you like this part of the review? Not this, I'm sure a lot of you will like this stuff, but this is important because it shows consistency going forward with more printers that I review. As for what I think about this printer, once again, Creality actually did a good job in terms of producing a 3D printer. There are a few things which I will talk about which I'm not entirely convinced about. However, in terms of reliability, it can handle it. Print quality is there again. The community that has been built around this printer is incredible. So you will always find help, and you always can upgrade this printer with parts which are being constantly uploaded by the community members of Creality. And let's face it, for $369, this has a really decent print volume. So you have 300 by 220 by 300. So that's definitely larger than average. And also the fact that it can print quite a variety of filaments. It cannot print any abrasive filaments because it does have a brass nozzle. So you will need to upgrade the nozzle in order to print in any other type of material that is abrasive. Another thing which I don't particularly like is the noise it makes. And it's not the printer itself that makes the noise, is the control box. And the reason for that is because it has 3 fans in there and they're constantly running at full speed, so it tends to be quite annoying. If you're in another room and you close the door, you'll be fine. You can possibly upgrade the fans, put Noctua just to make them more silent and maybe modify it a bit, but it's just something to keep in mind. Finally, the one last thing, and that is the price point. Now, while $369 for the build volume and the quality is not bad at all, I just don't understand why it is not cheaper, considering that the Creality CR-10, the full-size CR-10, is $30 more. It just doesn't really make that much sense to me. Now, this is the same price as the ANET E10, which is also $369. And if you're thinking to go either one or the other, please trust me on this, go with the Creality CR-10 Mini. However, if you're gonna spend that money, $30 more gets you a full-size CR-10, so I don't understand that price point. I think this should have been at least around $100 less than the full-size CR-10, even if it doesn't have the upgraded versions of the dual lead screws, the runout filament sensor, because that CR-10S runs to about $600 or $700, I think, at the moment. So yeah, definitely, I really think they should think about lowering this price. So that is it for me, guys. Thank you very much for watching. Please let me know what you think about this format or review in the comment section below. I'm sure it will evolve further going forward, and I will try to consolidate more information in less time just so it doesn't take that long. But I think it's a start, and obviously these changes are based on a lot of feedback that I got from you guys in the past year. So Any comments, any suggestions, please let me know and I'll work on it. I want to thank you guys for watching, and I especially want to thank my patrons for their absolutely awesome support. I also want to thank Filamentive for sponsoring this channel. Please make sure you check out their links in the video description below. That is all for now, guys. Thank you very much for watching. Please like, comment, share, subscribe, and as always, happy making, guys.